Right. Welcome to Breaking Badge. The, story behind your 44com badge, effectively. And that's by myself and... Well, am I calling you by your proper name or Phyushin?
Whatever.
Right.
Ed, right.
Ed the Duck, yeah. So... We're obviously celebrity lookalikes for Andy Crane and Ed the Duck. If you don't know who they are, Google them, please. Right?
You're obviously too young for this talk.
Yeah, and you're probably too young for it.
Hey guys, one second, that's alright. We can't fit in the room in front of the workshop, so make the spell set straight. I know the door open and I don't
You're supposed to block them from coming in. There's already too many people in here.
You're on candid camera, Sam. You know you're being recorded, yeah? Right, that's cool.
Yeah.
Alright. Okay. Right.
A lot of people disappoint that, isn't
Think positive, mate. Right. Okay. So, as I was saying, I'm Tim, this is Phyushin, and we're celebrity lookalikes for Andy Crane and Ed the Duck. We cracked that joke, nobody laughed, that's fine. I'm an ex-sysadmin doing management stuff, and Paul's a security tester.
Yes.
Right, and I'm Timmy Wimmy, and he's at Phyushin on Twitter. And we're definitely not replicants in any way, shape or form. Right, so the badge that you should all have hanging around your neck. You know you can get stickers for these as well, by the way. They are floating around, so you can have a police one, maybe the Tyrell logo on it. You can decide who you want to be. But they are based on the SLE 4442 chipset. And this is basically, all the cards are actually compatible. You can't buy a 442 anymore. Sorry, 344. Yes. Start again. A 4442 chip anymore. So they're all compatible ones, which is great fun. They are intelligent EEPROMs. They have 256 byte memory on them with write protection function and programmable security code. So that makes them sound totally secure. And they are compatible with ISO 7816 if you want to read and write them. And the data can only be changed after entry of the correct 3-byte programmable security code, or the security memory. And this is all taken from the datasheet, and this is exactly what it actually says there. All right? So you have pinouts for your data. As you can see, we've got 5 volts, we've got reset, we've got clock, we've got ground, and we've got data. So, say you're a man in the middle in this, and we'll show you how we did that earlier. We'll show you how we did it later in the presentation. This is the wires you want to connect up. There's a link in the actual thing for where we actually pulled this from, and as you can tell, Kinko, which is operated by FedEx, used to actually use this system for keeping track of photocopying. There was a DEF CON presentation where a lot of this stuff was actually revealed to be very, very insecure. The main reason being that this is the memory overview of it. As you can see right here, this read section. Oh, the laser pointer. Yeah, the read section does not require any form of security. So you can read these devices without knowing the PIN number. But if people don't change the PIN number, the default PIN number is FFFF, right? So, yeah, and remember, every time you don't change the default creds, God kills a kid. Yeah, this time it's that one. I'm not sure which one is going to be next. But, yeah, so going back to this a second. Yeah, so the only time that you actually need this code is to actually overwrite certain bits of data. But not necessarily all the data as well. Right. So, if you've got a card reader in your laptop, right, this one's actually from my particular card reader in my Dell laptop over there. It really hates these cards. You're pointing out my laptop. Right, okay. Yeah. It really, really hates these cards at all. I have no idea why. And yeah, same laptop, same software, just different card reader, will give you something like that based off exactly the same card. So if you are getting card unresponsive and you're using basically not the OmniKey 3021, that's probably actually where you're going wrong on this. Okay. My God, have I gone through that many slides? Right. Yeah. I need to slow down. Yeah. Right. So, software that you actually need. It's quite an extensive list. Yeah.
Script file as well.
Well, that's part. Right. So, the actual files you actually need to install are PCSCD, which is a daemon, which will handle talking to the card reader and communications. PCSC tools will give you a load of tools that you can actually then interface with the cards. And that'll interface with the daemon itself. So, two tools you can use are Scripter and Gscripter, which will allow you to read and write to the cards directly. But you do need to know all the bytecodes you're sending to them, which is great fun if you're trying to figure all that out. Right. If you're using Windows, so fortunately for you guys, it's actually part of the base operating system. Once upon a time, these cards actually allowed you to log into Windows, right? Because who needs Windows Hello? You know, just a card that you can arbitrarily clone and read. Yeah, it's fine.
That's definitely Ubuntu.
Pardon?
Somebody's over there doing Ubuntu.
Somebody, right.
Clink.
Right. Yeah. The apps are dependent on the reader. So literally you can go to OmniKey's website and actually download the software to actually read and write the cards for these. Like I say, the only thing you actually need is the default key, which is 3 bytes of FF. Right, okay. So if you wanted to man in the middle of these cards, because say somebody's actually changed the pin, and the pin is actually protected. So if you do try and brute force the pin, you're going to be out of luck. Right? You get 3 goes and then your card locks. You can still read it, but you can't write to it anymore. And that's it. So we actually did this. If anybody can spot the mistake on this slide, well, in the images. Right? Right. Right. This is actually conductive paint. This does actually work after a fashion, because I've got the card here. If you actually think about the pinouts, one of these pins is no connection. And I've put it as this one here, right at the very bottom. Yeah. Unfortunately, that one's actually one of the ones in use, and it's the one on the opposite side, and so I had to draw an extra pin in. So, yeah. I've actually got the cards that we actually use to have a play about with, if you want to have a look. Pass those around.
I'll come around and pass things.
Right. But effectively what you can do on this is just plug them into the card reader, attach your bus pirate, set the bus pirate up with the correct baud rate and speed, and then you can actually start intercepting all the commands as they fly over the wire and decoding everything. And this is how the original Kinko's hack was done. So he was able to get the pin number out of it, and then he could program up the card to do whatever he wanted, including changing his balance. He could, make it say that he'd actually printed out 20 things and yet still got a credit of £1 or $1 in this case. So you can literally change anything on the card if you've got the pin number. You just need to figure out what's the system for it. Okay.
Well, yes, the default key is 6Fs.
Yeah, that is the pin number. Yeah. Sorry if I keep changing between the two. Yeah. There is only one protection mechanism on these cards, and that is,
Is there a reset? Say 2 failed attempts.
Yeah. If you put the correct pin in, it resets to 3 again. No, sorry.
No.
After 3 is dead.
After 3 is dead, so it's only up to 2 reset.
Yeah. If you think about it, if you could reset it after the 3, then you've just violated your security control.
I'm assuming nothing else.
Yeah.
Yeah, they are. Yeah, they are what they are. Pardon? Right. Technically, you may be able to do that. You've got to decap it to actually do that, which we've not tried to. But as it is an EEPROM, and all EEPROMs will allow you to do it with UV light, potentially, yes, you could. Yeah. But you will reset all the data that's on the card as well at the same time. If they haven't put in place any extra protection mechanisms as well, and you don't have to shine it down at an angle, which is usually the way you have to do it. Okay. So, reading a card is basically as simple as you issue a command and it gives up the goods. It's really, really a cheap date. It's easy to actually do. And in the data sheet, the command is about, well, you tell it where you want to start reading from, and it'll give you all the information from that point onwards. So it's not particularly difficult to actually do. So when you're actually writing a card, you need to actually first issue a command to verify the PIN number. And assuming that one is successful, you can then erase all the card data, which is done no matter what you're actually doing. It will erase it, and it will write all ones to all sectors. This is probably why the PIN is FFFFFF as well. Because then, when you want to actually write data to it, it will and the data onto the memory. And so, yeah, that's why you'll find a load of the sectors on your cards will be FFFF all over the place when you're actually trying to read and dump them out. Yeah. Okay. So any questions about that so far? Predominantly, yeah. But most of the software you use will abstract that for you anyway. Mm-hmm. Right. So, thinking about the security model of this thing, since I believe there is a challenge actually for you to come up with a system that can actually use this card. Well, I want to say securely, but
I think the way that it was phrased was that it has to be, the security of it doesn't have to rely on the card.
Yeah,
but
basically,
it also does.
Yeah, if you use it, the card cannot actually make it any worse, right? So we've heard talk of PAM modules, so where it basically prompts you for who do you want to be. You plug in the card and it just logs you in. Stuff like that. But yeah, so when somebody actually did this, they must have thought about their security model. Well, I'd like to think they thought about their security model. This is probably the management part of me coming out, right? And obviously the CIA triad, because everybody loves that. So, confidentiality. It's my favourite thing in the world. Clearly not a thing on this card, right? You can read it regardless. There is no security controls to stop you whatsoever. And so, yeah. So if you're going to put any data on there, expect it to be cloned. Yeah. Integrity. So you do actually have some integrity in place, which is that PIN number, to stop it actually being changed. But, as we've discussed earlier, we can man in the middle of this thing, assuming it's not completely hidden. Certainly the card readers we've got, you can plug the card in and you will be able to get at the back ports of it. Availability. In general, if you've got these cards, you need a way of replacing them because they are going to actually get lost, get stolen, get broken. This is why they were used for Kinkos in the first place. And yeah, basically, if you lose your card, you can't then use it, but somebody else can. Make them come along, do it. So how are you actually going to use that to do something that's going to be securely? Really? It's difficult. The only thing that I could actually think of to actually use this is something that's going to hold an encrypted message, which is then validated by a backend. So if you store a hash of, say, a user ID and a transaction ID, and then you keep writing that transaction ID to the card, so it automatically changes, but it's encrypted on the card. If somebody clones it, then one of the clones is going to stop working, potentially. That's the only thing that I could ever think of for this. I don't know, maybe you guys have got some other ideas.
Interesting to see, wouldn't it?
Well, yeah, it would be interesting to see, and that's the basis of the challenge. So, right.
You'd have to have a pretty small key, though, wouldn't you? 'Cause
Right.
It's only 256 bytes.
Yeah. So, would you actually have the public key on the card or the private key, would you say? Okay. Right. Okay. So, people can still brute force your key. Well, yeah, you'd brute force the password. As Paul was saying, you can only have 256 bytes for your key.
Technically, you can only have 236 minus the 32 at the beginning.
True. Right, so
it's
you're...
small, it's shrinking, isn't it?
Yep. Basically, you get, what? That's 200 and...
20-ish.
Yep. So 220 bytes you're going to have for a key. That's going to be problematic. And also, if you lose your key, somebody else can read it, they can brute force it, they can do what they want with it. Potentially, it's a good idea, though. But, yeah. No. Jane?
So you talk about man in the middle. I've done that computer. So if the attack, there's a device, you put the card in, and then it writes the data to the card, and then your man in the middle things that.
Yeah. Right, fine.
Then, I mean, can you just pull the pin off some other way? So, like, decompile the firmware of the device that's reading it, or?
Well, if you can attack the software, we've actually had it, certain bits of software actually dumping out all the codes that they were writing to the cards and as they were reading. So we've actually done it from that side of things. This is what our readers actually look like. So who's actually got the card at the moment?
They're at the back.
Right. Probably nobody's going to be able to see this anyway. But, yeah, for the man in the middle, you can literally just plug it in like that, and all the pin contacts on this card are still intact. When you actually try and read it, it still works. But you've now got all these pins on the top, which you can then plug into your bus pirate to actually extract the information at the same time.
Yeah, but then you're writing.
Yeah, you'd still use the software to read and write from it, yeah.
So
Yep.
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 So that was.
Yeah, at Kinko's, he literally went into the shop and actually attacked this directly. Yeah.
You used the kiosk type thing, so you plug it in, pay money, but he had the thing sat on listening on the bus as the card was updated.
And so the pin was put on the kiosk.
Yeah,
Yep.
so obviously because he's intercepting the communication between the card and the machine, you could get all the traffic in that route. But that's the unlock. ADPU.
Yeah.
So you see the bytes coming through, but well, that's it. Let's dump the entire thing out, and then we can just rummage around.
But also, I mean, I guess you can get the firmware.
Yeah. Well, I mean, it's only sending you're sending like a bunch of bytes down, so you could even just have like a program. So that if for example, like those cards are the same sort of ones as the Slimming World cards. So the people who do Slimming World, they'll have like a PC with the reader set up, put it in, they run their program, which then sends the unlock code down and then writes to it. If anybody's interested, it does store your name in plain text on those cards, because I've got one. I don't know if it stores your weight in plain text, because I don't want to find that, if I'm honest. But yeah, so it's not necessarily like a hardware thing, because obviously some software will have those codes written in. We did find a Python library which abstracts a lot of the stuff, so you can just create little Python scripts that to connect to the card to read from it if you know the pin and you know the sets of byte codes to do those things, which are all in the data sheet, I believe.
Yep. Yeah,
I can talk.
right. But, yeah. Sure. Right. I think that's does anybody have any other questions at all? Yep. Yeah, they are pretty much. I don't know if you've got the data sheet on the actual...
I got everything that you put in the repos. So.
Right, okay. We do actually have a repository where we've actually just crammed in a load of stuff that we've been looking at, which we'll probably tart up a little bit and put online for you, including a Python script that I actually found that was, and still partly is, written in Italian. Right, the brute force button that's currently there does not brute force, because originally I didn't bother reading the datasheet that said, you'll lock your card out after 3 attempts. And so I pushed the button after writing it in this function and wondered why my card didn't work. And I went, it would be that. Yes, it now actually tries to do it 3 times and then stops. And it's always with FF, FF, FF. Yeah.
Possibly.
That depends on how you actually engineer it. You don't have to, because the software supplies the pin to actually do the changing. So in theory, if you can identify the card reliably, you could then have a different pin number for each card.
Yeah, because you can read without unlocking it. So one of the things you could have... Yeah.
Well, I mean, what have you seen in practice?
We've looked at a few, but in terms of the actual systems, they tend to actually have the same pin number.
So in theory,
Yeah. Well, going back to the Kinko's attack, what they actually did was they actually bought out a load of blank cards. So literally, these cards would have worked on it with the default pins, and they would actually detect that they got the default pin, and then reprogram them completely with the new pins. Because they'd go, this is a blank card, I don't recognise it, right, it's going to be wiped, and here's its new details. So, literally, they just overwrote everything. Okay. Right. So, we do have some card readers, if people want to come out and have a play. We've got about 20 of them. They will be around by the lockpicking village for the rest of the day if you want to have a go, see what you can do with the badge, try and have a read and write of it. We'll show you where all our repos are, and we'll put the repository online. Okay. Right. Thanks for your time. But, I realise we've only taken about 20 minutes and you got an hour, so if you want to come and ask us any questions, we've got all the stuff. You can have a play. Can't show you the man in the middle thing because I've just now broken it, but there you go. I do have the paint. We can fix it later. Right. Pardon? Yes, you can read the card without the pin, yeah. Okay, right. So the question was, can I clone if I clone the card, can I clone the pin? Right. No. Pardon? Right. Yeah, on slide 3. Right. So the slight thing is that it doesn't quite read everything on there. Yeah, it won't read the pin. That is the only bit that it will not read. So other than that, yes, it would clone everything.
So if you took a card that was written using a particular pin and cloned it, and then you had a card with no data with a different pin on it, it wouldn't affect the use of the data.
Right, so if I was using a card with a different pin with exactly the same data, no, it would depend on the system that was actually trying to manipulate the data and what it was actually doing with it. Because obviously it cannot then write the data, which may or may not cause an error. For me, I do have one question about the Kinko's thing, that if I actually programmed it up and changed the pin myself, would the Kinko's system actually go, oh, right, so you've got $1 on your account, you've done 10 copies, the value on the card is still, I'll try and decrement the amount, but it's still actually $1 because you can't change the value on the card. That was actually quite an interesting system that Kinko's actually came up with, because they actually stored the amount that you'd paid on the card itself, but all your transactions were in the back-end system. So you could literally see, oh, I've got a card that's blank and it's got $1 on it. You can clone it. And then as you go through, the guy bought a load of photocopies on there and put his cloned card in it and said, yes, you've done 20 photocopies and your balance is $1. So, yeah, it all depends on what you're storing on that card. And this is why I'd probably install something encrypted which you're changing every single transaction and keep track of it in a back-end system. Any other questions for anybody? No? So sometimes you have a magnetic stripe on the back. Yes. Right, so the question was, do you have extra protections if you've got a mag stripe on the back as well as the chip and pin? Well, the chip. Well, with the mag, you can read it because it's all in plain text anyway. But typically, as you see with these readers, you normally have a reader that's doing one job and not both. So it might be for compatibility reasons. Yeah. So I don't think I've actually seen a system that actually does both for verification. But again, it would be in plain text, so it'd be easy to manipulate one if you can manipulate the other anyway.
Yes. I'm just wondering maybe you could stick the secret code there and hash values.
Technically, you could have the hash valued on the mag stripe if you really wanted to, but like I say, you can manipulate the mag stripe just as easily. If not, actually, I dare to say it, but yeah, the chip is actually the more secure part of that system anyway. Yeah, and indeed, the one that I passed around for my man in the middle one has actually got the mag stripe on the back.
Yeah, that's what was asking.
Yeah.
Okay. You want
For Windows, HID actually have the driver software on there. So you should be able to find that on HID's website. Yep. I think we've got links knocking around somewhere, haven't we? Do you want to have a look in the repo, see if we actually put the links to where we found the things?
Yeah. Reader. So that's something I've been playing with.
Okay.
So that's the...
Yeah, the card manager, yeah.
Stuff. That was a bunch of
APUs.
APDs.
Yeah.
Yeah.
Right, okay. That's the psychogram. There's the date sheet.
Okay. Do you want that?
No, I was going to try and find the HID website. But literally, if you Google search for HID OmniKey 3021, you'll find the software for it. Mm-hmm. That's it. It's the HID Global OmniKey Workbench will certainly allow you to get diagnostics out there.
That one right there.
Yep.
So the datasheet and everything will be in the repository later on. We're just going to tart it up a little bit and then let people know where it is.
Yep.
I think I'll just tweet it to 44Con.
Yep.
That's probably the easiest way, isn't it?
Yeah, and we'll get it retweeted.
Yeah. Sorry? Yeah, so we've been using it's on GitHub. We're going to tweet the link out later.
Okay.
Right, okay, sorry. I'm like, yeah, that's the easiest way, and people are like, oh, no, I don't use Twitter. Right. Okay,
Well, if you come by the lockpicking village anyway, yeah, we'll make sure you find out about it. Yes, Jay? Pardon? The payment cards?
they're probably a little bit more secure than these.
Yeah.
Although you can read them with that card reader, it's not the same chip. So that's not the SLE 4442. It's got like challenge response type things and all sorts of other more complicated stuff because it's a bank card, obviously. Whereas these are just like something you put in a photocopier or I think in Germany they use them for like laundromat. You know, so you like just like a washing machine or whatever, you stick it in, whatever.
cards cost?
On eBay, I bought 5 for about £2.
Yeah.
But yeah,
Cheaper than RFID.
they're probably about the same. Like you can buy like in bulk, you'll get them cheaper, same as RFID cards, right? But you can buy them so you can get them with a reader as well. Like I bought a reader that doesn't work with these cards, so don't buy that one. And that was about 14 quid.
What does that work for?
So it reads other cards, but when I put in these cards, it just showed us it was unresponsive.
The one I got here was about 13 quid Amazon Prime, and it's full compact and it works.
It works, okay.
Yeah, like looks the ACR 38U chipset. ACR 38U is lost. Sell that chipset, and that works.
Or that reader?
That's
Yeah.
So that was the so that was the ACR 34U. You
That's
said
the Alpha Charlie Romeo 38 uniform.
38 uniform. Right. Right.
That chipset is used in dozens of readers. That's why it's got sports and stuff like that.
Okay.
Good idea.
Yeah.
Not like your Broadcom one.
Pardon? SIM cards.
I suspect they'd be the same, but I couldn't 100% say without getting one. Although it'd be a bit difficult to sort of get that in the card reader because you don't get the. Yeah, it'd be a good idea. Yeah, where are you going to get a full size SIM card from these days? Or like that?
Well, some of them come like that.
Those pirate probably.
Yeah. Incidentally, with the advent of flexible PCBs as well, you could probably actually build a better man-in-the-middle tool these days as well.
Anybody's listening to you.
But it's on the video.
Right?
It's on the video.
Yeah.
Okay.
Oh yeah, we recorded.
Did you have a question? Okay. Right. Right. Okay.
That's about it, right?
Yep, I think so.